Hello everyone, welcome back to Nated Engineering. We are still on Engineering Science N3, and today we are doing an exercise from the question paper that was written on the 17th of November 2016. It's question number 3, and we are going to start from 3.1. They say explain the difference between a resultant force and an equilibrium force. We know a resultant force is a single force that can replace two or more forces and still produce the same effect, while the equilibriant force or an equilibriant of a system of forces on the same plane is that single force which will balance the system of forces. That will be our 3.1. We move to 3.2. They say determine the magnitude of the forces P and Q shown in figure 2. The system is in equilibrium on the same plane. So the meaning of that statement, the system is in equilibrium on the same plane, they are basically telling us that the sum of the forces going to the right are equals to the sum of the forces going to the left. The sum of the forces going up are equal to the sum of the forces going down. So for us to be able to calculate for Q and P, we are going to start with the sum of the forces going up is equals to the sum of the forces going down. We have the first force that is going up is Q. Do we have another force that will be going up? The component of P, the vertical component of P will be going up. We know when the original force or the force that we are dealing with, which is at an angle, is pointing away from the point, also the component will be pointing away from the point, meaning the component will be pointing up. Therefore, we're going to say plus P sine 50. We are using the angle which this force makes with the horizontal, and that allows us to use a sine for the vertical component. We're going to say it's equals to this, the vertical component of this 500 Newton force will be going down. We know when the force is going towards the point, also the component will be going towards the point, therefore it will be pointing down. So it will be 500 sine 65. They didn't give us this 65 from the original diagram. They gave us 50 and this 65. So to get this 65, I said 180 minus 50 minus 65, and I got that this portion is also 65, because we know that the angle of a straight line is what? It's 180. We're going to say this is formula number 1. And then we are now going to deal with the horizontal. Let's say the sum of the forces going to the left are equals to the sum of the forces going to the right. To the right are equal to the forces going to the left. We are going to start with the forces that are going in that direction. We have 600 and we have the component of P. The component of P will be going to the left hand side, since it will be pointing in that direction. It's pointing away from this point. It will be positive P. It's a cos 50. We're using the angle which the force makes with the horizontal, allowing us to have cos for a horizontal component. It is equals to the component of, no, something it's not right. No, I mixed up two forces. 600 is going in that direction, and P and 500 are going in the opposite direction, meaning this is not an addition. We're not supposed to add here, but we're supposed to have the equal sign. Sorry about that. It's equals to, and this one is supposed to be positive, this side. Because we can tell that 600 is the only one that is going in that direction. The component of P will be in that direction, and also the component of 500 will be in that direction. Therefore, the component of P and the component of 500 must be on the same side of the equal sign. And then the component of 500 Newton is 500 cos 65. We only have one unknown in this equation, which is what? Is P. Therefore, we are going to say P is equals to 600 minus 500 cos 65 divided by cos 50. And that will give us the value of P as 604.696 newtons. We have the value of P now. We are going to take the value of P and substitute it in this equation for us to be able to get the value of what? Of Q. So let's write the value of P here to create space. 604.696 newtons. Let me erase all of this. We already have this, so I'm going to erase it here on my side just to create space. What am I going to do here? We have Q plus the value of P is what? 604.696 sine 50 is equals to 500 sine 65. The only unknown that we are having now here is the Q. Then we are going to have our Q, it will be equals to, the value of this is 453.154, and the value of this will be negative 463.224. This is the value of this 500 sine 65, and this is the value of this 604.696 sine 50. And we are going to get our value of Q as what? Negative 10.07 newtons. And that is how we calculate for the value of Q and the value of what? Of P. From there, we move to 3.3. Figure 3 shows a structure of forces in equilibrium. Analytically, determine or calculate the magnitude and nature of the members AB and AC. This is the diagram that were given in figure 3, and they are telling us to calculate for AB, which is the magnitude that will be carried by this member and the magnitude that will be carried by AC. And we also have to determine their nature. We know the nature is if the force that is acting there is a strut or a tie, compressive force or tensile force. So we're going to be dealing with this portion. First, let's calculate for AB. Meaning we're going to say the forces going up, the sum of the forces going up are equals to the sum of the forces going down. The force that is going up is 150. And remember, we have to choose a direction, so I'm going to choose this direction, going towards this point. And we're going to do what? Say is equals to the force that is going down. The force that is going down will be the component of AB, which will be AB sine 45. The only unknown that we have here is AP. Therefore, our AP is equals to 150 sine 45. And this will give us an answer of 212.132 newtons. The answer is positive, therefore the direction is correct. We mirror it, giving us what? A strut. We are going to move this so that we will be working with the horizontal. The sum of the forces going to the right are equals to the sum of the forces going to the left. Therefore, it will be the component of AE. Remember, we're only dealing with this portion. Never mind this sign. So this is going towards this point. Therefore, the horizontal component will be pointing in that direction. It will be what? AP. It's horizontal. Therefore, it's a cos 45. We're using the angle that the force makes with the horizontal. We have to choose a line for C. It will be in that direction. It will be AC. We have AB, therefore our AC will be equals to AP, which is 212.132 cos 45. And our answer here will be 150 newtons. It's positive, therefore the force is okay. We mirror the sign, giving us a tie. This is the magnitude, this is the nature. And the way we are calculating for the magnitude and of these members is called the analytical way. So this is what I had for this lesson. I will see you on the next one.